This video will be about how to use kinetic theory to explain the different gas laws, and how to use kinetic theory model to simulate all those in real life so that every students can really see the motion of the gas. Then let's start with the first one about the kinetic model. You really have to understand what is representing the different parts of the property of gas. Then we focus on this table here, this table. A diagram shows the mechanical model, which of following process can demonstrate variation of pressure with the volume fixed. Variation of the pressure with the volume of a fixed mass of gas under constant temperature. So that we try to give some symbol. Change of pressure with volume with a fixed mass of gas under constant temperature. This special brackets again about constant N and constant T. Okay? So that varying the weight of the disk. Yes, because this one is related to pressure. Changing the weight of the disk means changing the pressure. Varying the power, no, because power is related to temperature. The size of the ball, varying the size of the ball is in fact not an option of the kinetic theory model, but then if you really have to do it, then you are in fact changing the mass of the molecules. Next, varying the number of ball, that means you are changing the number of mole, N here, which is wrong. Adding a large polystyrene ball, in fact, no, because this is simulating a smoke particles. That means you are simulating the Brownian motion. So that's the answer should be A here. Next, again a very similar setup, and then this time you want to talk about the correct statement if the operating voltage increase. Operating voltage is related to the temperature increase. Then what happened? Then this will rise to a higher level. Then we have to talk about this by looking at the symbol. Because we are not changing the weight of the disk, therefore we are keeping the pressure constant because the disk is no changed. Pressure constant. Then when the temperature increases, you can feel that the volume will increase, or if you can't, then we use our very old school PV over NT here, and then we look at different thing. P is constant, N is constant. When temperature increase, volume must increase in order to keep R as a constant, because this is equals to a constant. Okay, so that V will increase. That means the disk to rise to a higher level to have greater volume. The average speed of the ball bearing increases. Yes, because you can feel it already. If your operating voltage increases, then you will have faster molecules being pushed out. Alright, so that this is correct. The average spacing of the ball, that means the density. In fact, we are talking about the density. Average spacing increases. Yes, because when you talk about density, you just need to talk about the volume. When the volume increases as statement 1, then the density will also, the density will decrease because the average spacing increase. This is correct. So that the answer is E here. Next, this is being trapped, so that by this we know this is a constant N. Now pushed slowly, that means the volume decreases, and slowly can help us to know that this is a constant temperature, and to be compressed as constant temperature, you can see. And which of the statement is correct? The average speed increases. Then you have to talk about the temperature. Now the temperature we know that is constant, so that this is wrong, should not be increased. The temperature is constant, therefore the average speed must be also constant, because this is the only factor affecting the average speed. Each molecule exerts a greater impact force in each collision. Now then you talk about the change in momentum. The change in momentum is mv, right? Then the speed is the same as statement 1, and also mass is the same because we trapped the mass, we didn't change the molecule, so that both will be the same, resulting that the change in momentum is also the same because the average velocity is the same as statement 1. The gas molecules collide more frequently with the wall. Then we have to talk about the speed and also the volume. Now we know that we have the average speed the same, and also the volume decreases. Same speed, but volume decreases, so that the frequency of collision must increase. And in fact, at the end, you will know that when frequency increases and the change in momentum is the same, in fact, the pressure will increase at the end. This is extra, so that this one is correct. Then the answer is boy. Next, energy is supplied to a fixed mass. Energy is supplied. This implies that the temperature has to be increased. With fixed mass, constant volume, which one is incorrect? The average speed of the molecules increases because the temperature increases, so that the average speed must also increase. Yes, average spacing increases. Average spacing increases because the volume is constant. No change, then the spacing must be having no change. That means the density is also having no change. Then this is wrong, should not be increased, should be no change. The gas molecules hit the container more frequently. The answer is yes, because the volume is the same. While temperature increases, the average velocity increases. That means the molecules move faster, then frequency of collision must increase at the end. Temperature increases, yes, because the energy increases. And in ideal gas, energy is represented as Ke. Therefore, the Ke increases. That means temperature increases. Yes. The pressure increases. Then we have to talk about the frequency increase and also the temperature increase. That means the average velocity increase. That means the change in momentum increase. Then by these two, frequency increase and the momentum change increase. Therefore, the pressure must increase because you hit more frequently and harder. Then the answer is boy, which is incorrect. And then next, we talk about a fixed mass, same constant N, is heated. That means temperature increase again. Constant pressure this time. Which of the following is correct? The average speed increases. Yes, must be, because temperature increase, then average speed increase. Very, very simple relation. The average spacing increase. Average spacing is about the volume, right? Then you have to think of the volume. You got two ways to do it. One way is to talk about this PV relation, which is a constant. Then you think of P is constant, N is constant. When T increases, then volume must increase. And when volume increase, spacing also increase. So that this is correct. Or you can use the microscopic view. This is the first one. The second one is you use the microscopic view. If the temperature increase, the average speed increase, then the frequency of collision will increase. Then the change in momentum will also increase. That means the pressure will increase. But then we need to have constant pressure, right? So that the volume has to be increased to maintain constant pressure. That is why when temperature increases, the volume increases to maintain the constant pressure. Then this is another way to think of volume increase and the spacing increase at the end, so that this is correct for statement 2. Lastly, the number of gas molecules remain unchanged. Yes, because fixed mass. Because n is constant. Okay, then the answer is E. And next will be a lot of explanation questions. You really have to focus on the exact wordings of explanation. Then let's try to look at it one by one. Everyone here is explained in terms of kinetic theory. Based on kinetic theory, explain. Use kinetic theory to explain. And then here is again, use kinetic theory of an ideal gas to explain. When you see this, you know you must be focusing on all those exact wordings here, so that you will be using the wordings here. Molecular motion. And let's try to explain one by one. Explain in terms of kinetic theory the increase in pressure when the volume decreases at constant temperature. Okay, 3 marks here. Then at least 3 sentences. Then here, what we have is, we firstly mention what is constant as the temperature is constant. Then the effect will be the average speed of the molecules remain unchanged. And secondly, now we have something changing. When the volume decreases, the molecules will hit the walls of container more frequently. When volume decrease, we talk about the effects of it, and then at the end, the pressure increases. So that you have to mention temperature constant. What is the effect? Average speed unchanged. Then volume decreases. What is the effect? Is that the molecules hit the wall of container more frequently. Therefore, at the end, pressure will increase. Next, explain how air pressure change. What is P change? When temperature increases with constant volume this time. Okay, again, 3 marks here. Then firstly, we say, as the temperature increases, the average speed of molecules increases. Next, as the volume is fixed, the air molecules, because it is now faster, will hit the wall of container more frequently, because the volume is fixed and it moves faster, and at the same time, because it's moved faster, it will hit more violently, more change in momentum, and at the end, the pressure, what is the change? Increases with temperature. So that this is the relation. 3 marks, 3 sentences. Next, now this time a gas bubble is rising from the bottom of liquid water, going up, so that you can see that the radius increased. This is a hidden information that the volume is in fact increased throughout the whole process. And we have to have an assumption, that is the temperature is the same, we assume. Temperature is the same of the water inside the lake with different height, a different depth. Okay, then here we get 2 marks here. Then we try to explain. The volume increases, but the average speed, we want to change in pressure. What is the change in pressure? Average speed of molecules remain unchanged. Yes, we assume same temperature and volume increases. So that's what is the effect of the pressure will be. The molecules will hit the inner surface of the bubble less frequently. Therefore, the pressure decreases. Next, this time we are pumping in air. We are using an air pump, and then you will be pushing the piston inward, and the temperature assumed to be room temp, which is a constant. Therefore, we have constant here, and then we are pumping so that N will be increasing this time. Then 2 marks here. Firstly, as the volume and temperature of the container and air remain unchanged. The number of molecules increases. With that, the molecules hit the wall of container more frequently. Because you have more molecules, then you have more frequent collision. Then the pressure increases. So that we got 2 marks here. That is, we have mentioned this is unchanged, and then if you increase the molecules, then it will hit the wall of the container more frequently. Then this is 2 marks because the last sentence is just referring to the question. Then this is how we are trying to explain in terms of kinetic theory. In fact, if you have recited all my example here, then you should be okay because we are just always repeating the same stuff. Hopefully you can get it. And then let's try to highlight this. Temperature increase, so that we say average speed increase. Volume fixed, therefore more frequently and violently. You can see all those physics terms here. Volume increase, average speed unchanged, therefore less frequent collision. Can you see? All those physics terms will be used. And lastly, we talk about 1 MC of the real gas and ideal gas difference. As long as you refer this table, I think it's okay. Which are the statement concerning real gas? That's correct. We look at the table at the same time. Collision between molecules and wall of the container not perfectly elastic. This is wrong. It should be both ideal and real gas are perfectly elastic in their collision. This is wrong. The volume of the molecules cannot be neglected. Yes, because this is not following the assumption of ideal gas. Intermolecular forces cannot be neglected. Yes. So that the answer should be E here. Okay, and that's it for the qualitative part. Next video we will talk about the math in this